Hello, everyone, and welcome back to the LeetCode Grind. Today we have 846 Hand of Straights. It says here that Alice has some number of cards and she wants to rearrange the cards into groups so that each group is of group size, which is one of the inputs, and consists of group size consecutive cards. So given an integer array hand, where each hand is the value written on the eye of the card and an integer group size, return true if she can arrange the cards or false otherwise. So right off the bat, we know that this must be partitionable by this size, number one, and number two, each partition must be consecutive. And for them, that means not just increasing, but increasing by one, by exactly one. They must be immediately increasing and consecutive. Okay, so this is actually initially, it was hard, but it's actually quite simple. We just have to use the concept of the hash map and counting each number. So I have an example here. It is one of the test cases. It's these two are default, and this one I added from one of the ones that failed, and I thought we can go over the workflow pretty quickly. All right. So the idea is so this is going to be our counts, and it's going to be a mapping. And the mapping will be of the different values. So here we have 6, 7, 8, 9, 10. So 8, 9, and 10. Now there's 6. I have it here. No, I have the counts here, which is 2. This is 4. 211, 2, 1, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And here we do sort. So this would be one loop to get the counts, and then we sort. So that's an log n. And going in the order of increasing of the keys here, we can say, all right, what's the group size? We start from the first key, and assuming that this is sorted, 6, 7, 8, 9, 10. We start over here and say, can we form two consecutive numbers of group size, which in this case happens to be 2, and to satisfy that condition, we need a 6 and a 7. Do we have enough 6? And remember, we're going to stay at each key until we exhaust it. So while that starting hand, which is 6 right now, while that exists, we're going to try to form a group size of 2 in this case. So 6, 7, we do. So that's great. We're going to make this, instead of 2, we're going to make that a 1. That's going to be a 1. Oh no, that's going to be a 3. 2 minus 1 is 1, 4 minus 1 is 3. Great, so we're done. We were able to partition a group. We're still here. Are there any 6s left? Yes, there is. So this now becomes 0. This becomes 2 because we're forming 6, 7. So we were able to satisfy. Now this is 0. So can we stay at this hand? No, because our 6 is used up. That's okay. We move on. Now 7, are there any 7s? Yes. So to satisfy the group size, we need a 7 and 8. Do we have a 7? We already checked. Yes, we do. Do we have an 8? Yes, we do. So this becomes a 1. This becomes a 1 as well. Awesome. This hand is done. Now we're still here. Are there any other 7s to satisfy? Yes, there's still 1 7 left. Okay, in that case, can we satisfy an entire hand of 2 consecutive hands or cards? We do. This becomes 0. This becomes 0. We're done. Awesome. No more 7s. Let's move on to the next card. Now 8. There's no more 8s. We've already used it up. That's okay. we just move on. Then we're at 9. Do we have any 9s? Yes, we do. We use that up. And then the next consecutive one is 10. So a valid hand would be something like this. We found a 9. Do we have a 10? Yes, we do. And at the end, the way we can satisfy the last condition of whether it is easily or equally divisible by this group size, we can basically just check if counts has any cards remaining. And that's pretty much it. And then we return the Boolean of that exploration. Okay, so let's try this. So what we did was basically we said, okay, let's get the counts of each card. And I don't know if that helps, but I'll leave this down below. Okay, now once again, we have the counts. Let's say we have the cards. These are all the cards that we need to process of the hand. This will give us this initial mapping. And then we're going to say this each key will be the start for start in. And remember, we want to go in sorted order. So sorted of cards dot keys. Okay. And we'll say while cards, well, we have the first card, the start. While we have it, we're going to stay at that start card and say for the card in range from start to start plus this group size. Now, here we check, okay, if we're out of cards or if the card we're looking for is not in this mapping or we don't have that card, then we can return false. And then otherwise, we'll continue to the next line, which is that the cards, that current card we're iterating between the start and the start plus the group size, we can decrement. Now, to make this a little easier to check, we can say, okay, so now if the cards of that card by this point is used up and it's 0, then why don't we just remove it from our deck entirely or from our hand entirely? So if we used up the cards, then just forget about that card. Okay, and at this point, in case we have some odd number of cards and they were all consecutive, they were partitionable, but we still have cards remaining because the group size wasn't equally partitionable, then we can say make sure that there are no cards remaining. And that's it. So let's run and give it a submit. There you have it. This is 846 Hand of Straights. Thanks so much. Happy coding. See you next time.